Okay, so the next identity that I'm going to prove is this one. Tan squared x plus 1 equals sec squared x. Notice, by the way, that when I write this here, I haven't bothered putting brackets around the x, and sometimes I did before. It's just laziness on my part. Strictly speaking, you probably should put brackets around the x's, and you can see on my theory notes that I do all the time. I'm just being lazy. So, tan squared x plus 1 equals sec squared x. Again, I've got squareds involved. So I'm going to go back to my identity. Sine squared x plus cos squared x equals 1. This time, I can see that I've got 1 as the second part, so I want to make that second part 1, so I'm going to divide everything by cos squared x and see what happens. So again, as long as I do it to all parts of the equation, then it's equal. So looking at this, well look, I've got sine over cos on the left, so sine over cos I know is tan, sine squared over cos squared then will be tan squared x, looking good. Cos squared over cos squared, that's just 1, and 1 over cos squared I know is sec squared x. I've proven the original identity, nice and easy. Now we're going to look at what happens when we have to prove something that's unknown, that we've never seen before. So here's a random formula, tan x plus sec x all squared is equal to 1 plus sin x over 1 minus sin x. And I want to prove that the left-hand side of this equation is equal to the right-hand side. In other words, I'm proving the identity. How do I prove it? Well, I could manipulate all kinds of things here, but it could get very confusing. So a general rule is whenever you're proving identities, just work with one side. Choose which one you think you can manipulate, play around with that until it equals the other side. That will help make it nice and clear and well organised. So looking at this, I'm just going to play around with the left-hand side, so I write in LHS to show that it's the left-hand side. What have I got? Well, I've got tan x. I know I can write that as sin x over cos x. I've got sec, which I know I can write as 1 over cos. All of that's in brackets and squared. Well, already I can start to see something I can do here. I've got cos x on the bottom of my fraction, so let's combine the two things together. So I've now got sin x plus 1 over cos x, all squared. Looking good, starting to look a bit like the equation on the right hand side. So let's have a look. What can I do? Let's split that up. So that I've got sin x plus 1 all squared on the top, and cos squared x, because it's cos x all squared, on the bottom. How does that help me? Well, again, thinking back to my identities, I know that sin squared x plus cos squared x is equal to 1. So I can rearrange that and know that cos squared x is equal to 1 minus sin squared x. So let's write that in instead. Sin x plus 1 on the top, all squared, and now I've got 1 minus sin squared x on the bottom. As you can see, it's now starting to look a bit more like the right hand side, but I've got some squares involved. And what you need to notice is various algebra. The bottom of my fraction there, I've got 1 minus sin squared x. 1 is a squared number, sin x squared, sin squared x. I've got a difference of squares. So what can I do with the difference of squares? I can split it into two brackets. So the top of my fraction, I've got sin x plus 1 all squared. So that is sin x plus 1 times by sin x plus 1. And the bottom of my fraction, I have a difference of squares, so I can write that as 1 minus sin x times by 1 plus sin x. So I'm using my algebra skills here. Now I can see I've got something on the top and something on the bottom that will cancel, because sin x plus 1 is obviously the same as 1 plus sin x. What am I left with? Well look, I'm left with 1 plus sin x on the top, just changing it around, and 1 minus sin x on the bottom, which is exactly what I was looking for to prove the identity. So I've finished. Just a bit of a tip. Quite often when we finish proving an identity, if we want to, we can write QED. It's Latin, it stands for Quod Erat Demonstrandum, which in Latin means, here's what I have just demonstrated. A nice little way of finishing off a trig identity when it's proven. Now that was quite difficult, but hopefully you followed the steps that I made.